like to know when we're does she need me as she breathes? Does she need me as she breathes? I'd like to know when we're in this war. Does she is this a war? Does she need me as she breathes?
Welcome to the physics of disc golf. In this video, we will discuss 3 physics concepts that are applicable to the sport of disc golf. Concept 1, elastic collisions. Elastic collision is a collision in which there is no net loss of kinetic energy in the system as a result of the collision. It is represented by the equation mass 1 times velocity initial 1 plus mass 2 times velocity initial 2 equals mass 1 times velocity final 1 plus mass 2 times velocity final 2. Nearly all collisions in disc golf are elastic because the objects don't stick together after the collision. An example of an elastic collision in disc golf is when the disc strikes the chains on the basket. This is an elastic collision because as the disc strikes the chains begin to move and the disc begins to slow down because the chains absorb kinetic energy from the disc. The second type of elastic collision is when a disc strikes an object but continues to move afterward. When the disc strikes the object, it transfers some of its kinetic energy to the object and the disc moves slower after contact. Some examples of this are trees, the ground, yourself, your cameraman, and trash. These examples show just how much of an impact elastic collisions have on the sport of disc golf. Concept 2, forces, specifically lift and drag. Lift is the force that allows the frisbee to stay airborne and in flight opposes the force of gravity on the disc's mass. The frisbee generates lift as it rotates through the air. Because of the way the frisbee is shaped, the airflow above the disc must travel at a higher velocity than the airflow underneath the disc, which creates a low pressure above and a higher pressure below the disc. This difference in pressures is what causes the lift of the disc, and which allows the frisbee to stay in air for so long. Drag is the force that works against the frisbee's movement while airborne and is opposite to the lift. The drag force, along with gravity, which acts on all objects the same, is what causes a frisbee to eventually hit the ground. Take this example of me throwing a disc. As the disc is on its upward trajectory, it is doing so because the air pressure above the disc is lower than the air pressure below the disc, which is causing lift, and that lift is causing the disc to climb in the air. While lift is occurring, drag is also affecting the frisbee. The point at which the lower pressure is below the disc and higher pressure is above the disc is the point where the drag force takes over and the disc begins to fall towards the ground. Topic 3, torque. Torque is a quantity that measures the ability of a force to rotate an object around some axis. Equation for torque is tau equals the force times the distance from the force to the axis of rotation, or the lever arm, times the angle between the direction of the force and the direction of the lever arm. This relates to a frisbee because the more spin you put on the disc, the more it will rotate around the center axis and the more torque that it will have. The higher the torque, the more spin, and therefore the farther the disc will fly. Different types of throws have different amounts of spin that they put on the frisbee. Some examples are the backhand. The most common type of throw in disc golf is the backhand. To perform this throw, the player rapidly draws the disc across the front of his body and snaps his wrist before releasing the disc. This wrist snapping motion causes the disc to spin. The spinning of the disc around the center of the axis enables the player to experience greater distance and accuracy with this throw, the forehand. Another common throw in disc golf is the forehand. This throw is similar to a sidearm throw in baseball. Although this throw does not get as much spin that disc gets to the backhand, it still provides an adequate amount of spin, which allows the throw to be used in both long-range and short-range situations. The hammer. The hammer, otherwise known as tomahawk throw, is a less common but still very useful throw nonetheless. It is gripped similarly to the forehand throw, but instead is thrown with an overhead motion. Immediately after being thrown, the disc begins to travel with the underside of the disc facing perpendicular to the ground. However, during flight, the disc eventually flips over and begins to fly upside down before coming in contact with the ground. After watching this video, I hope that you can understand why elastic collisions, lift and drag, and torque are all essential to the sport of disc golf. I hope you enjoyed the video, and thanks for watching.
But 100 points is 100 points. And physics requires us to get 100 points. Considering the 175 point final that we all just probably tanked. But because we all didn't tank the rest of the tests, we all still have A's. So it's alright. Isn't that right, Ryan?
Yeah, 100%.
100%. I got 100% one time. It was in a dream, I think.